So thank you everyone for attending this talk. Just for starters, just in case you didn't know, there is also a talk happening that is being done by Alex Soto and another one by Rosen Stoyanchev, in case you might be just in the wrong room. No? Okay. So yeah,
welcome to be the best one.
Welcome to our talk about the a survival guide to continuously align and upgrade your Spring dependencies. Let's start with the presentations. My name is Vicente Soriano, that's my face. I'm a software engineer at VMware Broadcom. We basically work on the Spring commercial team. Yesterday, Daniel in his talk described it perfectly. We basically build products on top of the already existent Spring framework and the entire ecosystem, and we deliver them to our customers.
Yeah. Hello, everybody. I'm Raquel. I'm also working at Broadcom. In my case, I'm not the software engineer. I'm a product manager, but I have a strong engineering background, and my expertise area is in compilers and as well tools related to perform code changes. And yeah, I hope that you enjoy this talk. And first of all, I want to make sure that you understand the flow that we are going to produce here, because maybe at the very beginning you think this is super basic, I need to go. No, please stay, because the best part is at the end, right? So first of all, we are going to do some basics about dependency management, probably everything that you already know, right? Then we are going to start and do some demos about what it means to do minor and major upgrades, especially in the context of Spring. And then goes the best part, which is the upgrade orchestration. What are those complex scenarios, right? Those non-happy paths where you have multiple projects that need to be upgraded, and there is a lot of team coordination, right? So please stay until the end.
Okay, so I'll take care then from the boring part. We want to start from the beginning. Probably most of you already know what dependency is. This is a definition given by Google Gemini. Everybody's nowadays using AI, so I thought, why not using it in this talk as well. This is basically the definition. It's a good definition, a relationship between software components where one component relies onto each other to function correctly. But I like to think, and I guess on a daily basis we like to think on a different scale, right? On a different approach, rather, which is every dependency that we use is nothing less than an imported library that can be leveraged to not re-implement something that we already want to do. It's already done. We are not going to reinvent the wheel. We have here an example. I'm sorry for using dependency not so well known. This one is from Spring Boot. It brings a lot of things to start you implementing tests and so, but yeah, it's a very well known one. And I mean, when we talk about dependencies and so, we are basically using them in the form that we benefit hugely from the work that others have done, the community is doing, basically everything that is around the open source world. And yeah, I mean, as we described before, we are not reinventing the wheel, right? We are benefiting from those. There is this caveat or drawback. Basically, we end up building applications, systems, infrastructures based on building blocks when we use these dependencies. And what it can happen is that, well, we end up using one of those dependencies that are maintained by somebody in Nebraska from 2003 or so. Not saying that it's dangerous, but it is. I don't know. Yeah, it's somewhat of a complicated situation. Anyway. Why are we going to talk about upgrades? Mainly because of this second topic, right? Vulnerabilities. Everybody knows what a vulnerability is. We want to avoid them, by all means. So CV describes a vulnerability like this. For us, I don't know if this is the implication, but obviously we don't want to have them in our application. We don't want to deliver them to our customers, and we definitely don't want them in our dependencies, right? What is being from a long time
a mantra.
Yes, thank you. A mantra from a lot of people, I wouldn't say companies, but maybe it is, I don't know. If it works, don't touch it. We are not going to follow this approach anymore. I don't think for software development either, I mean, not even recently, like ever, this thing was a thing. So we are not going to.
But I want to make you remember sometimes where people were excited to use the latest technologies, right? And at the end, the answer is there are no resources to change it. We are not going to upgrade it, and this is working, this is making money. Please don't touch it. Let's focus on the business value. And that thing, recently, I would say in the last year, right, has changed. And only because of security, right? It's interesting, right? For me, at least, it's something that made me think. And I want to, for instance, share here a personal experience. I was building a tool several years ago that were making code changes, right? And I was trying to automate those changes. That tool was called Walnut, and it was explained in several conferences, right? But at that moment, people were not interested to make those executions, right, or those upgrades. And basically the reason was because there was no motivation. It's simply a risk. So why you want to do that? Now the situation is completely different.
Yeah, exactly. And what, I mean, just to give an example or a use case that happened quite recently, already a few years ago, but probably it's still in everybody's mind. I don't know if any of you heard about Log4Shell. There's one's, yeah, it basically turned the world upside down. It made us just arrive to the office and start patching and upgrading everything just because of some stupid login library there that somebody tried to exploit and achieved it. Anyway, the third and last topic, I'm sorry for the boring part, but
Here's not boring.
yeah, what we want to define what we call projects, right? In this case, it says Spring Project, and you're going to see why. Basically, we are basically centering this solution, this approach on Spring projects, even though it applies to any other kind of project in the open source environment or ecosystem. When you go to Spring.io and try to keep to search information about a project to be used in your application, so basically it is a project, right? It's already described as that, and so basically what we want here is just to focus on that. We are going to repeat this word a lot, project, and we wanted to just clarify why we think the approach for upgrading your application shouldn't be particularly centered on dependencies, but rather on to projects. So projects are basically Maven artifacts, anything that has been published in a common repository or in an internal repository you can use, and basically share a purpose submission. They share the repository in which they are published, same functionality, and usually, which is important, a release cadence, right? A train of versions in which every dependency follows the same naming.
And the main reason why we say that there is a collection of artifacts is because at the end, lots of projects, if not most of them, have the structure of following a multi-module project. They are multi-module Maven or Gradle projects, and therefore all those artifacts in general are published simultaneously, and they have the same versions altogether, right? So this pattern is something that we follow in Spring, right? And we saw as well that at the end, several open source projects are following as well. But at the end, what we want to focus is at project level, because it is not, what matters is not the changes of a particular dependency, the changes or the upgrade part is associated to a particular project, because there are interrelationships between all those artifacts that have been published. That's the reason. And that's why some tools, for instance, might lack some functionalities that we are going to see later.
Yeah. So this is a basic example. You go to start.spring.io. You want to add Spring Security to your application. Basically, you are selecting the project here, even though it adds a couple of dependencies, and you can see those dependencies belong to two different projects, right? The first two belong to Spring Boot. The last one belongs to Spring Security. They are going to have different versionings and so, but basically this is the basic idea. So why are we, as Raquel just described, why are we focusing on projects? Well, you're using projects on your applications. You might be using the very basic example of Spring Boot. You are in 2.7. You need to think of an upgrade. you might think that, okay, in any of those steps, I want to at least reach any of those because I'm upgrading, hopefully the latest one. I'm sorry for not putting 3.5, it's already released, but I made the slides way before this. So. And this would be an easy case, right? Like, okay, I just need to bump the version, maybe fix a couple of things here and there, but that's it. But that's not usually the use case. The use case is that you imported Spring Boot because there are other things used in your application. For instance, the APIs called from Spring Security, something here or there, to access a database from your internal platform using Spring Data JPA, and so on and so forth. Now, there are underlying dependencies on these ones, even if you are not using them. Or you might, I don't know, Spring Framework and Reactor, for instance. And you start seeing that there are gaps in the versions, right? There are no versions related to Spring Boot 3.1 or Data JPA 3.1. If you're using web flags, what's going to happen, right? So, yeah, in this case, it's not that problematic because it means that those versions, Spring Boot, Spring Security, and so still work with Framework 6.0, but it is because it's Spring Framework. What if it's not Spring Framework, right? You need to be having this into consideration.
Vicente, I have a question because I see different versions here from different projects, right?
Mm-hmm.
How can I know what is the right version that I need to use, especially if I'm using a Spring Framework application, right? If I'm building that.
Good question, Raquel. Thank you. Next question. No, sorry. Yes. Yeah, what we have in the ecosystem for Spring applications and projects, it's, how to describe this? So, Spring Boot is usually the pivot project to be used in any of those Spring applications. You might be using every other, it doesn't matter, but the good thing that Spring Boot has is some artifact published inside its repository, and I think I have the link open here. This one, sorry, yes. So the artifact is called Spring Boot Dependencies. This is a very interesting artifact, mostly because when you are using the Spring Boot starter parent, it's using this one to just align a lot of versions for other projects without you noticing it. If you want to know exactly, if you're using 3.5, and you want to know exactly which version of Reactor you are going to use if you start using it, or you should use if you're upgrading, you can check here. This is basically Maven Central. It's hosted by Sonatype. But yeah, and here you can see all the, I don't know if it's, yeah, there you go. So the version numbers for all the other projects that could be used, mostly. Hibernate is there. Probably Reactor is down here, I hope.
Something that I would like to share
Reactor.
here, right, is at the end, as you know, there are hundreds of Spring projects. And every Spring project could be maintained by different people. And therefore, there might be kind of some inconsistencies between especially third-party dependencies, open source dependencies. And at the end, the question is, what is the right version to make sure that this combination is going to work between all together? The answer is these Spring Boot dependencies, right?
If you start needing to look at a plan for yourself or on your own, Spring Boot dependencies is a very good artifact. You also have Spring Cloud dependencies, same one but for Spring Cloud products. Spring Data and some other have their own dependencies as well because they have their particular train of releases. So that's a very good resource to know about.
And this is especially useful if you are building a Spring Framework apps. So Spring Boot has everything already solved, right? Because you are extending from a parent dependency. But if you are building a Spring Framework, you lose that thing, and therefore that is the source of truth, right? About what version you should combine.
Exactly. This is a very good point because, as you can see, I added a new line, which is Hibernate. This might be also a new dependency that I need to update in my application. And if I'm following the train of releases of a Spring Boot, or in this case Spring Data, because it might be one of the sub-dependencies used by that project, you can see a gap between 3.1 and 3.2, which is it's skipping 6.3. Now, why is that? Well, mainly because they chose that particular version of Hibernate when they released that version. Does it mean that Hibernate 6.3 is going to work if I upgrade only Hibernate? Possibly, but we don't know. And if you go and check Spring Boot dependencies, you still don't know, because Spring Boot dependencies is telling you that if you're going to use 3.2, you should use 6.4. That's what they tested, and that's what towards their community is provided in the form of a suggestion. But that's not the end of it, and it becomes more complicated. We add a new dependency, but this one is not below Spring Boot. This one uses Spring Boot, and it has a different cadence of releases. The alignment is totally off the grid, right? We have now 3.3 that doesn't align to anything, so what do I do? If I upgrade Spring Boot to from 3.3 to 3.4, is Java CFM going to work? Do I need to skip one of Java CFM? This becomes really, really hard, and it cannot stop there. It can even have more of those dependencies. And all of these are open source projects. We are still not counting your own internal components or projects. So you can see that this is quite a hard task in order to come up with Kekaku plan. Yes, upgrading your application. So basically here what we describe is that normally it involves just bumping the versions of the dependencies projects that you are using. And here we just listed that, well, if it's a newer patch version that you have to do because there was some bug solved or some CV addressed, usually the effort is minor. Just put the new patch version there and it works. You could upgrade to a minor version. That's the effort. It's a little bit more complicated because depending on which project you are upgrading, you might be introducing breaking changes. Not every project uses semantic versioning, and you might not know. And
what would be the best way to know if there are new versions available? Because at the end, you know, no? At the patch versions might be because there is a bug fix, or it could be because they have already resolved or remedied a particular vulnerability. So what would be the recommendation to keep your applications updated?
Yes. So, I don't know. No, I mean, probably most of you already know this, but the usual way to follow in order to keep this upgrade, to acquire this culture, part of the culture of the continuous upgrade, is using automatic tools like Dependabot or Renovate. Most of you probably are already integrating those in your pipelines. And yeah, that's normally the usual good way to go, even though if it doesn't address any more things, at least the bumping of the numbering of your versions is still addressed by that.
And I also want to highlight here or ask somehow, do you know if those tools know the interrelationship between the versions of the dependencies that you need to manage?
I think they don't know about the interrelationships, which is why it's so hard to upgrade certain applications. So
all right.
It wasn't correct?
Yes.
Yeah, and newer major versions usually involve changing the major version. Yay. But that's probably the biggest effort you have to do because there might be breaking changes, and so, which is what we talk here about. You are not only usually changing just a number and, hey, I upgraded my application. No, you probably need to address those breaking changes, something that was changed between versions. It can be names of methods, types that have changed, parameters or arguments that are different in this new version. I don't know, annotations that have also been changed. It can be anything, basically. So those are what basically complicate your upgrades. There are also deprecations, things that are not used anymore, and there is nothing here rather than just going to the release notes that says, hey, you should not use this anymore because we are not giving support to this. You should use this other thing instead. It's also a good change that you usually need to do for your application. And lastly, but not least, changes in best practices. We all want to follow this when we are using any kind of dependency, any kind of project. There are usually recommendations by, I don't know, the author of those projects, or they are some sort of de facto standard from the industry. We've seen this since, I don't know, Java, the earliest versions of Java. When Java 8 came, it introduced streams and optionals and those sorts of things, and there were new and better approaches to, I don't know, fix null values and those sorts of things, right? At least treat them and so. So that would be part of what you would do for upgrading the application. Now, this is the first demo. This is going to be so simple. You're going
the idea of this demo, basically, we want to show you what it means to simply upgrade Spring to the next minor version, right? We have seen that minor version might require changes or not, because at the end, at least in the Spring world, right? When we provide a minor version, it means that some methods have been deprecated, and therefore it's an opportunity to use the new APIs instead of moving all this technical debt until the new major version. So, yeah.
So basically here I went to start Spring IO, downloaded the application, changed the version of Spring Boot Starter that it's being used. I imported a couple of dependencies for Spring Web, so it's, well, they both belong to Spring Boot, but I'm going to use Spring Web, so Starter Web is there. And yeah, it's using 3.3, which is not the latest, already pretty outdated, so we need to change it, right? We need to upgrade. And yeah, let's take a look at the project itself. So this is the structure of the project. Basically, we have a Spring Boot application, nothing new here. I'm going to have a controller defined here. Basically, this controller represents what the courier would do, which is basically delivering a Platinum chip. This is follow New Vegas stuff. Yeah. Sorry? Oh, yeah, sorry. Yeah, sorry. Is it good? Yeah. Thank you. Thank you. And yeah, it responds basically with a string. Nothing fancy here. We have an implementation here for the tests. I'm going to increase. There you go. So yeah, basically an integration test for checking that controller is responding correctly. It's giving the expected string, and that's it. I'm going to run the test, and this hopefully works because this is my application, right? This is the status of my application. That's it. Let's go into upgrade it to the next minor version. This is very simple, but then again, I'm trying to perform an upgrade in my application. So is it okay? I think it works. So let's go to here and say even clear package and test, do everything, and yeah, hopefully downloads internet and fails. Nice. There's a type clean instead of clear. Is it the? Oh, sorry. Good audience. Thank you. Yeah. If I put the wrong goal, that's going to happen. So as we can see, Spring Boot application was initialized, and it's already in the version that I want to, and test passed. Almost everything is correct. So that's how you upgrade your application. Thank you very much. No, okay. There's more to it. Sorry. Go, Raquel.
Something that I would like to highlight here is that this is how Spring delivers software in minor versions, but there are as well other open source projects, and some of them are also part of the Spring dependencies, I would say, that because they are, let's say, just beginning to exist, right, they are introducing as well breaking changes in minor versions. This is something that you can experiment. So that's how Spring is delivering new releases, but this might be not the experience for other open source projects. That's just the...
Yes. So we want to immediately continue to, okay, we described already the breaking changes. What happens if I need to change something that it's no longer available, something has changed? At the version bump that I did, it's not helping, okay? At least it's not enough. And we want to present here, and for those of you that attended the team's talk yesterday about Assert J, it was not about this, but he mentioned it. It's a very nice tool. But yeah, we need to, we hopefully need to use some sort of tool that leverages this kind of process and help us addressing all those changes that are needed, rather than just having to go ourselves into the release notes and doing manually these changes. It might not be one line, it might be 100 lines. It might affect different projects across our portfolio. So we don't know. We need a tool, right? And then we present here player 2, which is OpenRewrite. Now, who does here? Yeah, sorry.
Yeah, exactly. So could you raise your hand if you are already using OpenRewrite or you have heard about it?
I think, what if we do it on the other way around too? Has anybody ever heard about OpenRewrite or never used? Good.
Okay.
Good. Take this as a takeaway, and that's it. No. No, this is a fantastic tool. It's very, very powerful. Okay, it's going to help you do the upgrading, right? At least leverage most of what you need to do. And basically, we listed here a couple of advantages that it has. First of all, it applies refactors with accuracy. Mostly the technology that it uses loads your application in the form of what's called lossless semantic tree, which is a representation of your code, but maintaining all the types. And correct me if I'm wrong, the types, the names.
I hope that you probably have used already checkstyle, PMD, this kind of static code analysis tool. So the main difference is that those static code analysis tools are basically parsing the source code, but only the text representation, all right? OpenRewrite is not only parsing the source code, it is taking advantage of internal compiler APIs to resolve the type of every single expression. And therefore, it's able to let you program or define the way that you want to change your software, and do that with accuracy. If you remember when you execute checkstyle or PMD or even SonarQube, right, there is the chance to have false positives. That's the main reason. It's because they don't have this type inference as part of it. With OpenRewrite, you can program your refactors and get the same experience if you were doing that with the IDE. Another characteristic that is relevant is when you are modifying sources, and this is not something super old, right? Usually the tools were simply applying those changes in memory and then bumping them in a particular style. So they were using a formatter after that. And then it was super difficult to understand what were the original changes that you were introducing, because you know, right? It's a full reformat. OpenRewrite is understanding what parts of the text need to be changed, and therefore is not reformatting the whole file, and it's easy to review the impact of a particular change, which is usually called recipe, right?
Yeah, exactly. So in other words, whatever you use that touches your indentation, the indentation you're using on your lines, it's basically messing with you. You don't want that, right? You want anything that helps you upgrade, but leaves the code as it is because you want it like that. So yeah, that's the second line. You can see here one of the things that Raquel said. Recipes. The concept of recipes is what OpenRewrite uses for applying those changes. Basically, they can be atomically created to just address a couple of those changes. Method name that has changed. I don't know, a class that has also different parameters in the constructor, whatever. And you can also compile those recipes with other recipes and then keep creating something that is more complex. They provide the tools for you to write your own if you're delivering some sort of library for your own organization. And they can also they provide you like with 3,000 recipes in their catalog, which address many of the open source projects. You need to check if yours is there, but yeah.
Also, I would say, an interesting fact is that this tool was born at Netflix, because they required to do some refactors regarding the logging library. They need to move to Log4j, if I'm not wrong. So this was born at Netflix. Now this project is owned by Moderne. You have the standard if you want to check it. But the author has moved, and this project is completely now owned by Moderne.
Mm-hmm. Yeah. Any kind of information that you want, go to the booth, and they can probably give you more and better information. We've used it, and I mean, it's amazing. Very good recommendation. And lastly, but not least, yeah, it uses Maven or Gradle, so it can be applied into your Maven or Gradle projects.
Yeah, so OpenRewrite is not a CLI tool per se. You should execute that through Maven and Gradle, and the main reason is because OpenRewrite needs to load your class path to understand the types, right? And it's Maven or Gradle who can deliver that information.
Yeah. So let's go with the second demo. Explain a little bit what we are going to try here. Basically, it's mostly the same. I did download another new application from Start Spring.io. I imported also Spring Web to create a couple of controllers. Let's take a look at the POM XML. Basically, this is the main inner structure. I changed the version of the Spring Boot dependency that I'm going to use. I'm going to use 2.7. This is even more outdated than the one that we showed before. And yeah, you see the dependencies here, same as before. Now, the demo, I called it Green Fandango. I don't know if any of you have played the game. Also good recommendation. But basically what we have is Spring application. I'm going to show here the record that I have for representing, sorry. There you go. Representing, can I apply it to every window? Okay, thank you. We'll see. It's just the opposite of pinching. So we have a record representing the customer, right? Customer, the main thing that it has is we need to say if it's a good or bad person. We have the travel agent. Travel agent basically sells packages to customers. That's it. And we have a controller that I created. Right? Controller is called Department of Death controller. And basically this controller, what it does is sells travel packages for every customer. Now, there's a particular thing that I want in my Department of Death, which is, so good. If the type of person that the customer is of a good person, so basically if the customer is a good person, I don't want to sell any travel package. I'm going to retrieve it and keep it. And basically the controller is going to respond with a response status exception of type or a status code of 406, not acceptable. Otherwise, we sell the package. Yeah, well, basically there is another one here which pairs it both together, but yeah. I have here two integration tests that test this functionality works correctly, and it only tests the functionality, sorry. It basically, yep. So basically the first one tries to, and it fails, nice! Class loader.
Try to reimport your project.
Let's try to do this. Because when we start changing version numbers, whatever is.
Delete the test. And run configuration for the test. Maybe you have some parameters.
Where is that? Where's here?
Yeah.
Okay. Yeah, let's remove all of those. I'm not sure. Okay. Good thing I recorded this before. So let me skip until where this was already executed. So here, yes, this is the part that I'm already running the test. Yeah, they are green. I cannot pinch this one, sorry. I cannot. I cannot. But yeah, I can basically switch over to this thing. Yeah, integration test. I'm basically testing that the first customer that arrives is a bad person, and Manny Calavera can sell the travel. No problem. So you enjoy your trip through the land of the dead. Second one, Merche, not so good for her, at least. She's a good person, but basically when we need to retrieve the travel for her, when the travel agent needs to sell this travel package, it receives a non-acceptable. There is an extra test that I implemented here, which is just a unit test of the controller in which I'm particularly checking that the status that it responds whenever there is a good person as a customer, it's not acceptable. Now, this is going to work as well. I'm not going to run those other tests, but this test runs correctly. My application, even though if it's outdated, the test still fit for those. Yeah. Basically here, what I do is, rerunning again the application, compile it, and I'm going to stop here because I think the rest should work. I don't know. Now what I'm going to do is upgrade the application, right? But in order to upgrade, before I just bump the version, I don't want to do that. Basically what I want to do now, and let's see if this works, is apply this. So this thing here, I don't know if we can read it. Hello.
Well, this is executing OpenRewrite as a Maven plugin, right? It's including the rewrite Spring recipes, right? It's using the latest version, and then it's selecting the specific recipe to upgrade, which is upgrade Spring Boot 3.0.
To 3.0. That's the landing version that I want to obtain, right? I was not expecting to download internet again.
It's because you are using the release tag, and maybe they have released.
Okay, that makes sense. But yeah, it ran the recipes. It did something. There is some information here, but probably the best way to say this is just do a git diff and see what changed. And now we see that I didn't touch any part of the code, but it changed the version number, but it also changed the method getStatusCode. Now that method, if I try to run an upgrade to 3.0 without changing that, that's going to fail, because getStatus is a method that was already deprecated for the response status exception class. Right? So this tool already helped us to upgrade the application. Basically what I have to do now is, if I accept these changes, just commit to the repository, and I already have upgraded my application. It's not up to date, still needs more work to do, but hey, it's just the first step towards having it upgraded, right? Yeah, and I'm going to hand it over to Raquel because you're already tired of hearing me.
All right, so we have seen, I would say, one very basic upgrade, then we have a major upgrade, but what else could be worse, no? Well, the bad news is that usually it's even worse. And I want to give you an example and guide you through it. So this is the classic use case that you have seen in the previous picture already, but guess what? Spring usually is one of these blocks, right? And Spring is relying on other open source projects, and you are probably consuming other open source projects that are using Spring, and you have your internal libraries as well, that if you love Spring, why not? They are using Spring. And this creates a chain of upgrades, right? So what at the end means? So there are three different challenges from our point of view when you are doing a major upgrade. Basically, and that's an important thing, several projects need to be upgraded and released. So you need to orchestrate an upgrade across different projects that probably, and I would say 90% of the cases, means that several teams need to be aligned in terms of priorities. And what does it mean? Lots of meetings. Second, well, we know that there is a recipe for Spring, but there are many other projects on top of Spring, right? All they should build recipes if we want to do the thing in the right way and be efficient. Well, you are going to see that maybe yes and maybe not, because sometimes if they are, I would say, upstream dependencies, they might not introduce breaking changes. They are simply, they are gonna upgrade the Spring or any other project, right? And their APIs are still the same. So why you should build yet another recipe? Why it's worth the effort? Because, yeah, we've seen there are lots of blocks on top of these common frameworks or common utilities, right? So it's going to be a pain if every single one needs to build a recipe, and you need to wait for that recipe to happen, right? So we are going to explore that part. And then the latest, but not the least, is that some of those projects won't accept to upgrade. So that has happened. There are many, I would say, relevant projects that rely on Spring, and they are not gonna publish new releases. They have stopped. And in those situations, you need to migrate. You need to do migrations. Indeed, it's even happening inside the Spring. There are projects in the Spring Boot 2 to Spring Boot 3 from the security part that are no longer available. And this is a spoiler of what we are going to see later on, right? But it means that you need to move from those projects to Spring Security, for instance. They are moving parts, and you need to do that migration as well. And that's the concrete example that I think that is going to be quite common, that I would like to elaborate with you all, right? In terms of, well, what does it mean to move from this situation to the next version? Particularly, I'm using a Spring Framework 5.3, which is no longer in support, which means that you are not going to receive patch upgrades anymore, and you are going to be exposed to vulnerabilities. And the goal is to be in support again. To be in support again, I want to upgrade to Framework 6.1, right? And then I have my Commons library, the Acme platform library. Everybody has a Commons library. And that library is using a Spring Framework, right? And guess what? We have other modules that are super nice, which are Acme recommendations, Acme payments, in this case, or Acme settings. Some of them uses some modules of Spring, and some others uses others. It's in purpose that I'm using a Spring Framework to make it even more complicated, all right? And Acme recommendations is using integration, security, Acme payments, security, and security RSA. And and also using Acme platform, right? And Acme recommendations, which means that the upgrade needs to happen in a particular order. Because otherwise, what is going to happen is that it's going to be a mess in terms of dependencies. And you won't even know if the application is going to finally work, right? So at the end, the question is, what's the plan? And to be concrete, what is the upgrade plan? Well, let's start from the very beginning in terms of best practices, right? I have a platform, which is in 5.3, and then the next step is going to be Framework 6, and I'm moving that to a snapshot. Why? Because at the end, it's a good practice to do an incremental upgrade when it's possible, because you have more control about the changes that are needed, and you are not introducing noise. So this team is going to do this upgrade to 6.0. And then, after they are ready, they are going to release, because that's the goal, use a supported version. It's going to use Framework 6.1. In the meantime, everything can continue and everybody can work as usual, right? Nobody is blocked because they are using pinned versions. And then when Acme platform is ready, then the other team, which is Acme settings, this is why I'm using different colors, right? Can start the upgrade. And this upgrade needs to happen from 5.3 to 6.1. They cannot do this intermediate step, for the same reason that I was explaining about mixing dependencies, right? And now we have Acme recommendations, which in this case is not only using framework, it's using integration and security. They need to do a composite upgrade. So yeah, we have this intermediate step, which is on a snapshot. Then we can continue, but guess what? There is another intermediate step before moving to Framework 6.1, which means that I have more control of the changes again, which is Spring Integration 6.1 and Security 6.1. And then finally, we can move to Framework 6.1 and move integration, and then release. Now, this is going to unblock Acme payments, right? And Acme payments now can upgrade because my dependencies are all aligned, right? And have you found something missing here? Acme payments is this one. Don't be shy.
RSA?
Correct. That was a spoiler, right, that I was mentioning. RSA is no longer available when you're upgrading to Framework 6. And therefore, there is a migration involved here, because it needs to be replaced by Spring Security. Cool. And this is the final picture, right? We have these 4 teams that they have incrementally upgraded, and finally, they are in support. So, what if I run, or what would be, I would say, the problematics when I'm using OpenRewrite to do this kind of upgrades? Well, basically, OpenRewrite is not going to know anything about your internal projects. It's simply going to upgrade Spring. So you might, if you don't pay attention about what are your dependencies and who needs to upgrade first, then you're going to see a lot of changes, and then you're going to start spending time to figure out why not. Okay? And there is, I would say, a best practice followed by most of the open source recipes in OpenRewrite, which means that those recipes are including best practices. So they are including optional changes, right? Which means that at the end you're going to see many changes as well, which means many noise. This is not the practice that we really recommend. And finally, yeah, go ahead.
Looks good to me.
And finally, to make it even more complex, because OpenRewrite doesn't know about what is your concrete version that you are running the recipe, it's applying all the changes required in all the previous version. Right? Maybe you are running the recipe to upgrade, I don't know, to framework 3.4, right? And you are in 2.6. It's going to execute everything, right? And this means that you're going to even see even more changes, because guess what? The recipes, if I'm in boot 3.4, the first line is to upgrade to 3.3. And then it produces a chain or a cascade of changes of all these versions, which is usually the reason why sometimes people complain and say, hey, can we make this or split this in small versions? And another part of the analysis that you need to do is to really understand what is the target version. And sometimes it's not clear because you depend on other external dependencies. And something that's as well that has been a learning from us, from real use cases, is that when you are creating a recipe in OpenRewrite, and you can see that as well in the Spring recipes, those recipes are invoking recipes to create the dependencies, their own dependencies. And guess what? Dependencies are not provided at the same time than when a project is released. Recipes might exist anytime in the future. That's a general fact. So, if I'm a recipe provider because I have a project and I want to let others upgrade my APIs, does it make sense to figure out where I should publish a PR to say, hey, now, because you're using my dependency, you need to upgrade, you need to use my recipe? No, it doesn't scale, right? That's the thing. Or you, as an application developer, right? Should you figure out what recipes need to be executed together? It's hard, right? So at the end, our recommendation is that recipes should only provide the changes of the APIs of the corresponding project, nothing else. Because what is a fact is that you need an engine or something that figures out what recipe needs to be executed together. That's the summary, right? Recipes shouldn't include upgrades to previous versions or dependency versions, because at the end recipes are published in the future of that release. And that something, right, that needs to figure out what recipes need to be upgraded together is something that we are providing in Tanso, which is Application Advisor. This something, or Application Advisor, is calculating the upgrade plan that we were doing manually all together in the previous slides for ACME. And you can see what are the steps to upgrade my application, right? What dependencies can be upgraded first? What are the minimum changes that need to be applied? And guess what? If I'm relying in internal dependencies of my project, it stops and says, hey, you cannot continue with the upgrade until that team provides the configuration with the recipes to let them upgrade. Then only if that team provides that information, the upgrade continues. App Advisor is simply best for a Spring because it provides out of the box more recipes that are part of the enterprise package to cover the most important Spring projects, which means boot, framework, security, data, and integration. So we have a catalog of hundreds of recipes, and it's incrementally growing. One?
Yeah, we have the demo.
Yep.
Can we do it? I mean, we are on time, but if we can quickly take a look at the demo 3 folder that we have here. I can do a quick one. So in this particular case, what we have is what's called Acme Boot Starter. It's basically a component. I'm going to list what's here. It's in the latest version, but if I check my repository for that, not this one. My repository for this component, which is this one, I see that there are a couple of releases that we've done, right, since from the 1.0 to the 6.0. And just for you to understand it, 1.0 started with Spring Boot 2.7, and the latest one is up to 3.4. So it basically followed the same train of releases as Spring Boot, this component. If I go back and I go to my main application, which is Spring Pet Clinic, in this case I didn't use video games, sorry. I can see that I have, POM XML, and my application is in 2.7, and if I go to the dependency list right here, I can add a dependency. Probably it's better if I do this in IntelliJ, right? For whatever reason. Pet Clinic here, POM XML. There you go, / yeah. So I can do group ID. The group ID is com.acme.boot. The artifact ID, I don't remember, so I need to check. I think it's a good opportunity also to describe this. Basically, what we have in that file, we need to extract the information of the versions, right? We need to explain this. We have a file here, which is demo3. This is basically another thing that the advisor does, is creating a mapping of versions for this particular project. It retrieves information and meta information, like for instance, the coordinate that I need to use. In this case, this is what I was looking for, the repository and a mapping of versions. Basic information, which version of the artifact exists, to which version it evolves or upgrades, and if there are any, which supported generations, which versions of other projects are related to this particular version, right? This is the way we have in order to do the alignment, or at least provide some information for the alignment that we saw before in the table that I showed. So I go here, I put this artifact ID, and I'm going to tell this application it's going to use version 1.0.0, right? This is it. This is basically a dependency that I added for it. And the last thing that I need to do, but I'm not going to do it yet, sorry. Pet Clinic. So I'm going to use Advisor. Let's see if it's available, just in case. That's H. It is in the path? Right. Okay, so this is the CLI that we just basically worked on. We can do Advisor build config, as you see here, the first subcommand will extract information from the application needed to apply upgrades, but maybe for something else as well, to provide advices and so it's probably the first thing that you need to do. I already did. And upgrade plan, get, no, I don't know. This is fantastic. But I have a video. There you go. There you go. This is what I wanted to show. So when you do upgrade plan get, it's going to complain. It's going to tell you, hey, there are upgrades for framework, boot, data commons, but there is a component blocking those. I cannot upgrade it for you. So what you do afterwards is basically that file that I extracted from my component, I provide it through an environment variable, like this one, Spring Advisor, mapping custom, and then a series of configurations if there is the need, right? I just basically export it into a variable just to have it available for when I run the command, and then just later I execute the same command that I put there. It's basically the same, but just with a environment variable. And when I execute it, I obtain something a little bit different, which is what we've been describing towards the entire talk, right? An upgrade plan.
Exactly, and this upgrade plan is doing those incremental steps, but now that we have the mappings, you see the demo 3 Acme boot starter is part of the upgrade. So App Advisor, when we run Advisor upgrade plan apply, it's going to execute all the recipes associated with those upgrades, which might contain hops, right? Like this one, like Hibernate, or not, or it could be the next incremental one.
Yeah, basically the summary of all of this is that the table that I was representing before, which was hard to come by if you're doing that inspection, this does it for you. And I think that's mostly it.
Yeah.
Yeah, that's it. We ran out of time.
We are running out of time, but if you want to ask us any questions,
we can be around here.
We are going to be here.
Booth. Thank you very much.
Thank you.